Hello students, today we will discuss the Runge-Kutta method of second order to solve the ordinary differential equation. So, first of all, let us discuss the procedure. The procedure will be like this: dy by dx will be given in the question having the function of x and y of x0 means the value of y at a particular point of x, that is x0, will be y0, means the value of y at x0 is y0, and h, which is the common difference between x0, x1, x2, will be given in the question. We have to find out the value of y at a particular value of x. So, what will be the procedure? First of all, we have to find two parameters, that is k1 and k2. So, k1 will be h into f of xn yn. It will be made clear in the next example. K2 will be h into f of xn plus h yn plus the previously found k1. And what will be yn plus 1 means next value of y will be the previous value of y, that is yn, plus average of k1 and k2 means half into k1 plus k2. This procedure will be go on repeating. Okay. So, let us start with an example. Question, that is dy by dx, it is given in the question, is equal to y minus x. Y of 0 is 2, h is 0.1. You have been asked to find y at 0.2. Okay. Let us compare it with the procedure. In the procedure, dy by dx is equal to some function of x and y. Here dy by dx is equal to y minus x. So, here f of xy is y minus x. Clear? Next, in the procedure, the value of y at x0 means here the value of y at 0 is 2, the value of y at x0 is y0. So, here x0 is equal to 0, y0 is equal to 2, and h is already given in the question, h is equal to 0.1. Okay. Now, we will find the k1 first. K1 is, as per the procedure, h into f of xn yn. In the first case, xn yn will be x0 y0. That means h into what is f of xy here? F of xy means y minus x. So, what will be f of x0 y0 means y0 minus x0, h into y0 minus x0. So, now k1 will be h is 0.1 here, y0 is 2 here, x0 is 0 here. So, 0.1 into 2 minus 0, that is 0.2. Here the value of k1 is 0.2 here. Now, what will be the value of k2? K2 will be, as per the procedure, h into f of xn plus h. Here it will be x0 plus h, yn plus k1, that will be y0 plus what is k1 here in the previous step, that is 0.2. Okay. So, now h into f of x0, x0 was 0, 0 plus h is equal to 0.1, that is 0 plus 0.1, that is 0.1, y0 was 2 here, 2 plus 0.2, that is 2.2. Now h is 0.1 into f of xy. Here it is y minus x, f of 0.1, 2.2, that means 2.2 minus 0.1. Now that is k2 0.1 into 2.1, that is 0.21. So now k1 is 0.2, k2 is 0.21. So k1 is 0.2 and k2 is 0.1. Now y1 means y when x is equal to x1. x1 means x0 plus h means 0.1. y1 means y when x is 0.1. That will be previous y means y when x is equal to x0, as x0 was 0 here. So y when x is equal to 0. So y when x is equal to 0, it was 2 plus average of k1 plus k2. k1 was 0.2 plus k2 was 0.21. It will be 2 plus 0.41 by 2. 2 plus 0.41 by 2. The answer will be 2 plus 0.41 by 2, 2.2050. It was y when x is equal to 0.01. It was the first iteration. In the next iteration, we will determine y when x is equal to 0.2. Okay. So now x1 is 0.1. y1 means y of 0.1 was 2 point, just we have found it, 2050. H is already given 0.1. Now next k1 will be h into f of x1 y1. That means 0.1 into f of x1 means 0.1, y1 means 2.2050. The value of k1, now it will be, let me write the value directly, that is 0.2105. Similarly, the value of k2 will be h into f of x1 plus h, y1 plus k1, which was found previously. That was h into f of x1 plus h means 0.2, y1 was 2.2050 plus k1 means 0.2105. So k2 will be the value of k2, as after calculation the value of k2 will be 0.22155. Now y when x is equal to x2, when x1 was 0.1 and h was 0.1, so x2 will be 0.2, 0.1 plus 0.1. y of 0.2 will be y when x was 0.1, that was 2.2050, because yn plus 1 was yn plus half into k1 plus k2, plus half into k1 was 0.2105 plus k2 0.22155. So value of y when x equal to 0.2, it will be, after calculation it will be, let me write it directly, 2.4210. This is the answer. It was asked in the question, find the value when y is equal to 0.2. Some parts might not be visible, let me This is the second order Runge-Kutta method. Thank you all.